When we think of the stars of the animal kingdom, we often picture the megafauna: elephants, hippopotamuses, rhinoceroses, and big cats, for example. The vast majority of this world's animals are, however, invertebrates. There are an estimated 5.5 million species of insect known to science alone, and many more still waiting to be discovered. Billions upon billions of individuals lead complex lives in the undergrowth that most of us aren't even aware of. Some, such as the subject of today's video, have taken things a step further than a mere life, however. Beneath your homes, in your gardens, across your local parks and out into the wider world live millions of unseen kingdoms. These kingdoms, composed of legions of ants, operate like complex societies where castes and classes create functional communities that keep their world turning. Much of this goes on without most of us noticing, but studies into the lives of these tiny insects have proven that they are more involved than we ever realized. Almost 14,000 of an estimated 22,000 known species have been classified by science, which makes it very hard to pin down just one species of ant to focus on. Today then, we will be examining ants all over the world. From the tiny 0.8 millimetre long Carebara atomi to the 4 centimetre long Dinoponera gigantea, let's unearth the alien world of the ants. In short, an ant is any one of the 22,000 known species of insect in the family Formicidae. Ants are very easily recognizable insects, identified by their antennae articulated at a sharp angle and their tiny segmented bodies, which often end in large abdomens. Ants have existed on our planet for an estimated 113 million years, when they evolved from flying wasp-like animals in the Cretaceous period. The first true ants would have formed colonies and built advanced social lives when some of the largest dinosaurs were passing by over their heads. Today, ants can be found across the whole world and have been introduced to most of the landmasses on record. While ants have been introduced to parts of Antarctica, they are not native there, and today are absent from only the coldest regions of the continent, as well as a few of the most remote islands in the middle of our oceans and seas. They are most common and numerous in tropical rainforest ecosystems and tend to favor warm reaches of our world, but the cold doesn't put them off. Some ant species are equally at home in Siberia or northern Canada, as most would be in the Amazon rainforest. Central and South America, followed by equatorial Africa and Asia, have the most species of ants, which range massively in terms of size, form, and behavior. Ants are distinctly different from other insects, with some morphological differences being more obvious than others. An ant's antennae is elbowed at a sharp angle, and they possess a node-like segment connecting their thorax and abdomen, or gaster. An ant is covered in an exoskeleton, in place of an internal skeleton that would be found within a vertebrate. The exoskeleton protects the ant from physical harm and attaches to the muscles to allow the insect to move. The exoskeleton also holds various tiny holes known as spiracles, which act in place of an ant's lungs. Inside the body, a nerve cord that anchors the nervous system runs along the length of the body. Towards an ant's head, sensory organs are abundant. These organs help the ant to detect food or danger in its surroundings, while its compound eyes, composed of many tiny lenses, help the insect to spot movement and signals from other ants. The antennae are used for homing in on chemical signals, air currents or vibrations in the ground, while a pair of strong mandibles or jaws at the front of the head help the ant to carry food or build a nest. In some species, the jaws are extremely powerful and can provide a painful bite. Within certain species of ant, individuals may look different. These varying forms are known as castes and can range massively in size, strength, form, and ability. The smallest and most basic form of ant is the worker. All worker ants are females and cannot breed. Instead, they spend their entire lives foraging for food, building the nest, caring for the queen ant, and defending the colony when it comes under attack. Within colonies, different groups of workers may focus on one of these roles, specialized to complete the task efficiently. Workers are the most numerous of the castes in a colony and are essential to the continuation of the group. Within some species, workers may be derived once more into soldiers, a specialized caste that are specifically responsible for the defense of the colony. Soldier ants usually have enlarged heads and more powerful jaws, and can also carry larger food items when they're not mobbing a foe or defending the queen. In most species, the most prominent and numerous groups of males in a colony are the drones. Typically, these are the winged flying ants who often have only one role in life: to mate with the queen ant and further the colony across future generations. When the mating season arrives, drones will take to the skies in what is known as the nuptial flight, mating with virgin queen ants and usually dying soon after. They typically only live for a few short days and are not involved in the general day-to-day running of a colony. This is why, in most regions, you typically only see flying ants for a select few days across the course of the year. The largest and most focal ants within a colony are the queens. Some ant species have only one queen per colony, whereas some species tend to have several. Queens can often be identified by their large abdomens. They are the only members of ant colonies who can bear eggs and mate with the drones over the course of their life. In a single lifetime, a queen ant can produce thousands or even millions of eggs that will develop into workers, soldiers, drones, or new queens. While genetics play a large role in influencing which caste a future ant will grow into, environmental factors like food type and amount can be important too. Once a queen ant has mated, she will usually find a new location to start a fresh colony, digging into the earth to lay more eggs. Via the use of pheromone signals and chemicals, she will influence other ants in her colony. Worker ants will bring her food and care for her throughout her life, which can sometimes span decades depending on the species. Without the queen, a colony will soon wither and die out. Intelligence and complex sociability is not something we typically tend to associate with most insects, but ants demonstrate capabilities unique to many arthropods. An individual ant may not be able to demonstrate, say, complex reasoning or thought, but together, these animals form a swarm intelligence that works shockingly well. Ant colonies can learn to associate chemical signals or smells with rewards and use pheromone trails to communicate and determine the locations of food and foraging sites. Ants within a colony work closely together to solve problems within the group. This could be defending themselves against attack, finding a safe or efficient path to food, or dividing labor amongst groups of workers. One of the ants' most impressive feats of coordination and intelligence is their construction capabilities, building complex nests to keep them safe from the elements and predators. Some species of ants spend more time and resources on constructing a nest than others. Nests can be as simple as short tunnels, or as complicated as a large network of underground chambers. Some ants construct hills or mounds, such as the over 200 species of fire ant that live across the world. The ants do not enter and exit their tunnel via the mound, but rather from numerous radiating tunnels that project outwards from underground chambers. Colonies are formed when a mated queen leaves her old group to form another. She will be pregnant with, in some cases, thousands of eggs that, in the first generation, will all be workers. She digs a simple burrow, lays her eggs, and sees them through to maturity. This first generation of worker ants will begin to take care of her, whilst digging larger, more complex burrows and tunnels underground to expand the colony. Over time, as ant numbers expand and the tunnels grow, the colony will grow in strength and will become more capable of sustaining itself, both against the elements and predators. In a few ant species, some colonies can grow so large they are dubbed supercolonies. Supercolonies usually form near to human settlements, where hundreds or even thousands of individual ant colonies join forces to target and eradicate other species of ant in the area. Conflict and competition amidst supercolonies can cause millions upon millions of individual ants to die as calculated attacks and defensive operations are planned. Let's take a closer look at what those attacks can look like. Ants will fiercely defend their queen with their lives. To lose the queen would mean the collapse of the entire colony. And due to their large numbers and demand for resources, they sometimes find themselves coming into direct conflict with other colonies who are also trying to expand and survive. Ants will tend to operate in a determined territory, and when other groups of ants encroach or attempt to threaten that territory, things can get violent fast. Ant will rush to the defense, mobbing and biting their opponents. In some species, however, only the physically stronger soldier ants will be used. Either scenario can result in up to tens of thousands of ants present in a given battle. In some instances, a clear winner will be obvious, but in the event of skirmishes or brief battles, ants can return to the same site later to see off any future threats. It is not unheard of for entire colonies being wiped out entirely in these wars, which can result in the death of a queen or the capture of larvae, which will in turn be assimilated into the invading ants' colony. Ants that die on the battlefield will most often be eaten by the survivors. This saves time on foraging, where numbers after a battle may be lower. Just like in humans, ant warfare can be calculated, and strategies are employed in some species. Some, such as the 200+ ant species in the genus Carebara, arrange themselves in phalanx formations to provide the best lines of defense. The phalanxes slowly move across the battlefield towards the attackers, who may also be in formation, holding their ground fiercely as they advance. Some species will even send workers in first as a front line of what is essentially cannon fodder, to distract, tire and pick off the enemy front line, while the soldiers can move in as a second, stronger wave. Even more surprising is some ants' capability to use pheromones to mask their scent, sneaking into an opposing colony to steal resources or kidnap larvae. Amidst the thousands of known ant species, some have stood out as being particularly unique to science, given their strange appearances, unorthodox habits, or dangerous natures. Ants have had a long time to adapt and evolve into numerous different forms, sizes, species, and niches. And while all ants are unique, there are some that are much stranger than others. Perhaps the strangest looking of all the ant species are the members of the genus Cephalotes, colloquially known as turtle ants. Soldiers of these species are known for their bizarre, extraterrestrial-looking heads, which are broad and flattened to provide the ultimate defense. When the colony comes under attack, soldier cephalotes ants will effectively plug the tiny entrances to their colony using these heads. The heads are tough and resilient to the bites of other ants, which makes it very difficult for invaders to breach their home. Even stranger is that these ants don't even typically construct their own colonies. They overtake abandoned beetle nests within wood and bark. Their heads have adapted to be just the right size to match the holes created by the beetles. What's more is that, given these ants' habits of living high up in the treetops, some species are adapted to gliding with streamlined aerodynamic bodies that let them gently drift back to the colony if they fall. Some worker ants from the genus Myrmecocystus are known as honeypot ants. These unusual insects are known for their comparatively gigantic abdomens, which become bloated with the sugars, liquids, and fats that they store inside their bodies. These reserves provide nourishment for other members of the colony as a backup larder when times are tough. As such, these workers, known as repletes, are kept in the deepest parts of the colony where they are heavily guarded to stop invaders from stealing their food. Humans will even seek out these ants for food, which can often be found suspended upside down from chamber ceilings. Other ants take construction to the extreme, utilizing their adaptations in creative ways to create defensive homes for their young. Ecophylla smaragdina, otherwise known as the weaver ant, is one such species. These insects will sew together leaves in tightly connected nest-like structures using silk. This silk comes from weaver ant larvae, which, when combined with the strong jaws of adult ants, can be used in construction. The larvae are carried around in the mouth parts of adult ants as they go about this task, while others reinforce the structure with twigs and detritus from the forest. These leaf nests can provide efficient defense from predators and can conceal their young while they develop and mature. Ants in the genus Odontomachus are fierce carnivores with some of the most elaborate jaw mechanisms in the animal kingdom. Broad and serrated, this weaponry can be sprung shut in the blink of an eye when prey items brush against the tripwire like hairs lining the center of the jaws. They have the fastest bites amongst any known carnivore and can close their jaws so fast that they double up as catapults. If one of these ants finds itself in danger, it can press its jaws to the ground, triggering the mechanism and propelling itself out of harm's way. The force generated from the jaws closing is 300 times greater than the insect's overall body weight, meaning they can travel far and fast in a single quick movement. Other ants are known for their extremely potent bites and stings. While red fire ants can inflict irritating burning sensations across the skin of humans, some species are notorious. One such species is Dinoponera clavata, lovingly known as the bullet ant. Native to Central and South America, the bullet ant lives in colonies at the bases of trees and have become infamous in the natural history world. The sting of the bullet ant ranks the highest of all known insect species on entomologist Justin O. Schmidt's Sting Pain Index. Schmidt himself has been stung by the ant and describes the sensation as akin to walking over flaming charcoal with a 3-inch nail embedded in your heel. The insect's common name comes from the comparison of its sting to the sensation of being shot, and those who have been stung note the presence of uneasing pain for up to 24 hours. Humans who get stung can expect to feel burning, throbbing, the swelling of the lymph nodes, fluid retention in the region of the sting, a racing heart rate, and blockages to the nervous system. In Brazil, the Satere Mor people use the stings of bullet ants as a rite of passage ritual for individuals seeking to become warriors. In these rituals, 80 live ants are affixed, stinger first, into a woven glove. Smoke is blown onto the ants to make them agitated before the initiate puts his hand into the glove, leaving it in there for between 5 and 10 minutes. As you can expect, this would cause unimaginable pain. In some circumstances, this ritual will need to be repeated up to 20 times over the course of several years for a young man to be fully initiated. Given their small size and large numbers, ants across the world find themselves as prey items for vertebrates and invertebrates of all sizes. While ants have developed strong bites, stings, and swarming tactics to defend their colonies from attack. Some animals are very well adapted to breaking through their defenses and consuming the insects within. The most obvious predator of ants are the animals that are directly named for the behavior: anteaters. The giant anteater, native to South America, is one of the most efficient predators of these insects in the world. Armed with a long snout and even longer tongue, the anteater will use its broad, sharp claws to dig into ant nests. The tongue is sticky and flexible, and when launched into the broken walls of a colony, will be able to consume thousands of ants in one sitting. Several animals have convergently evolved the anteater lifestyle and body plan across the world, including aardvarks in Africa and numbats in Australia. Animals as small as shrews and as large as bears will sustain themselves on ants where they can. Bears tend to favour ant larvae, while shrews and moles target ants to supplement their primary diets of worms. The most common and persistent threat to ant species are birds. Some species of woodpecker, such as the green woodpecker, are adapted to living primarily on the ground, where they use their long beaks and tongues to extract ants from the ground to eat. Other birds, such as sparrows, wrens, and nuthatches, will pick off ants where they can amidst their wider diets of seeds and nuts. Predators invertebrates at ground level can also provide a threat to ants, including spiders, assassin bugs, beetles, hornets, and antlions. Even other ants, such as those in the genus Phytole, will consume smaller species of ant when available. These little insects need to be constantly vigilant. One wrong move or a failure to defend the queen could result in the deaths of their whole colony. What happens then when a queen dies? Well, the first and most obvious is that there will be no future generations of ants produced, most likely leading to the eventual death of the colony. Worker ants have very limited lifespans, and without their numbers being constantly topped up by a fertile queen, they will be unable to sustain their populations. Worker ants will continue to perform their general day-to-day duties around the nest when a queen dies, but their behavior will become much more erratic without the pheromone signals produced by the queen to guide them. Some worker ants could, themselves, develop their reproductive organs, but won't be able to lay fertilized eggs that hatch into new ants. In most species, this will spell doom for the colony, but some ant species have managed to find a way around even this. Indian jumping ants, for instance, will engage in duels to determine which ant will be selected as a new queen. Once a new queen is chosen, the colony can recover and continue without issue. Disaster can strike ants in many ways outside of sudden death and predation, and one of the most bizarre examples of this is the ant mill, otherwise known as the death spiral or circle of death. This phenomenon can take place in army ants, one of any 200 or more species known for their extensive foraging and raiding parties. Army ants typically follow pheromone trails laid down by individuals as they move through the undergrowth, which effectively tell the ants where to go and what to look for. Occasionally, however, things don't go to plan, with disastrous effects. If a group of ants becomes separated from the main foraging party, they can lose the pheromone trail and begin to follow each other instead. Each ant will simply follow the one in front of it, rather than the main trail, and will become trapped in an endless spiral of rotating ants. This behavior can eventually bring the ants to exhaustion, resulting in the death of those separated from the main trail. Similar behavior has been subsequently recorded in some species of caterpillar, and even in fish. Perhaps the most unpleasant natural threat to ants is Ophiocordyceps unilateralis, a species of pathogenic fungus that thrives in humid tropical rainforests where large numbers of ants live. The fungus is parasitic and lives to spread its spores across the rainforests as far and wide as it can. What better host than millions upon millions of tiny insects that travel far and wide? An ant can unknowingly be infected by the parasitic fungus as it forages for food in tropical forests. The spores will attach themselves to the body of the ant, which will slowly begin to permeate the exoskeleton and dig deeper into the body. At this point, there's no going back. The ant is infected and doomed to the fungus's influence. As Ophiocordyceps works its way through the ant's system, it targets the insect's neurological system, forcing it to act in unusual ways. The fungus will hijack the ant's ability to think, forcing it to head into even more humid areas where the parasite can grow effectively. Mindlessly, the ant will climb to a point roughly 10 inches off the ground, where it will proceed to latch onto a north-facing leaf vein. Here, the ant will simply wait for death as the fungus grows out of its body once more, before spreading its spores into the air, ready to start the process once more. The fungus is thought to be capable of overriding not only the ant's mind, but its muscle system too. The ant will be entirely enthralled, physically unable to fight against the fungus's influence until it eventually passes away. As humans, we tend to go about most of our lives unaware of what goes on in the kingdom of the ants. As creatures that are so small, they have little impact on our day-to-day modern existence, but they have gone on to inspire many works of fiction and folklore over the years. In ancient Greek mythology, ants on the deserted island of Aegina were transformed into humans by Zeus and came to be known as the Myrmidons. The Myrmidons were said to be descended from the Myrmidon himself, the son of Zeus and Eurymedusa. Eurymedusa was said to be seduced by Zeus in the form of an ant, who in turn gave birth to Myrmidon. In Japan, to dream of an ant is to obtain a sign of coming fortune and wealth. Ants are generally seen as good omens, symbols of good health, and are appreciated for their hard-working natures and social intelligence. The word ant in Japanese, when written, is composed of the characters for courtesy, unselfishness, and justice, and the insects are appreciated in several folk tales in the country. The dream of Akinosuke is the most famous of these, which centers around the character of Akinosuke, a farmer who falls asleep under a cedar tree. Akinosuke wakes to the presence of a royal procession, whom he agrees to accompany to the king's palace. Akinosuke agrees to marry the king's daughter, but his newfound wife soon becomes ill and passes away. The farmer erects a monument in his wife's memory and holds a funeral, before receiving a message from the king. The king tells him he will soon return to where he came from, and to not worry. Soon, Akinosuke finds himself waking up underneath the cedar tree once more. He was dreaming. What has seemed like years to him was just a few moments in reality, and one of his friends informs him something strange happened while he was asleep. A yellow butterfly had emerged from his mouth, but was soon grabbed by a passing ant. When Akinosuke woke up, the butterfly reappeared next to the tree, unharmed. His friends believed the butterfly to be the farmer's soul, and upon closer investigation they saw a vast colony of ants beneath the cedar tree. Akinosuke recognizes the colony as being the very kingdom he visited in his dream, complete with the same monument he built for his wife's passing. Beneath it, he finds a single female ant buried in a coffin. While some cultures around the world eat ants as a source of protein and fiber, we do not typically farm them as domestic animals. Ants are sought out and collected by forager cultures, particularly in South America, where they are used as snacks, stir-fried condiments, and in some regions, traditional dishes. Eskimos, eaten in Mexico, consist of ant larvae and pupae, whereas leafcutter ants are eaten in the Santander region of Colombia. Ants are typically seen as a sustainable food source in the regions they are consumed, but it can be dangerous to eat them. Ants could be infected with parasites, and many species deliver painful bites and stings, making it hard to obtain and prepare them. In modern times, myrmecology, or ant farming, has become a semi-popular hobby in some parts of the world. The hobby involves effectively keeping ants as pets to observe and care for them, helping people learn about their behavior and biology. While commercially sold ant farms are typically small and unethical for colonies, suitable habitats crafted with care, when enough access to food and water is provided, can see colonies flourish under the watch of humans. Species such as the black garden ant and various members of the harvester ant genus, Mesor, are typically used in the hobby. Despite the fact that thousands upon thousands of species are known, scientists are still continuing to learn about ants and their behavior. There are, without a doubt, many more species out there waiting to be discovered and described, each with adaptations, defenses, lifestyles, and castes of their own. They are one of the most overlooked yet complex animals in our world. Intelligent, hardy, and at times dangerous. The next time you see an ant or two in your garden, stop to take a moment and think. That's the product of millions of years of evolution, fine-tuned to one of the most unusual and highly adapted insects in the world.